Hello everybody, this is Mr. Aguirre with another tutorial on how to do this week's assignment. This week's assignment is calculating postmortem interval, or PMI, using two things, rigor mortis and Algor mortis. So the first thing I'm going to do is I am going to explain what rigor mortis is. So if you look over here on the right, rigor mortis is the stiffening of muscles in the body. And this happens over a period of time when somebody dies. So the first 2 hours show no stiffening whatsoever. But after 2 hours, from 2 to 6 hours, that's when rigor begins and the body becomes stiff. Now here's the thing. So the stiffness only starts in smaller muscle groups. So most of the time it's usually only in the face, and then the bigger muscle groups like the arms and the legs will start stiffening as time goes on. After 12 hours, peak rigor is exhibited. So the whole body is just stiff. This is when people who die of holding something in their hand, it's really, really hard to pry it out of their hand. After 15 to 36 hours, rigor is uneven, so you start to lose some of that stiffness, and that stiffness is gone in the places where it first starts. I know it sounds a little weird, but if it starts in the small muscle groups, that's where you lose it first, right? Rigor slowly is lost first in the muscle groups. So it starts first in the smaller muscles like the face, and it is lost first in the smaller muscles like the face. And then after 36 to 48 hours, there's no rigor whatsoever. So your body is all loosey-goosey. Next, there are different factors that affect rigor. So the first one would be temperature. So if it's cold outside or inside, wherever the body is found, it's going to inhibit rigor, which means it's going to slow it down. If it's warm wherever the body is found, that means it's going to speed it up. So your body is going to tighten up a lot faster. Activity before death, if somebody was exercising, then that's going to accelerate rigor. And if they were asleep, it's going to slow it down. And finally, body mass. So if somebody is heavy, it's going to slow it down. So rigor isn't going to happen as quickly. And then if you're thin, rigor is going to happen extremely quickly. So using this information, we can really start to answer these questions over here on the left. Now, let's look at this very first one. It says a body was found with no evidence of rigor, right? So this means two things. One, rigor begins after 2 hours. So after somebody dies, after 2 hours, that's when rigor starts. So either this person just died, or after 36 hours, there's no rigor. Rigor is absent. So one of two things happened, right? Either number one, they just died, or number two, they've been dead for 2 days. Now, if you don't know where I got 2 days, 48 hours is 2 days, right? 24 hours in a day, 24 times 2 is 48. There you go. So let's look at this next example. It's pretty simple, right? Body was found exhibiting rigor throughout the entire body. So the whole body is stiff. Now, when is the only time that the whole body is stiff? Let's look at this chart. Let's see. Stiffening begins. Nope. Entire body is rigid. Oh, what is that? Bagoosh. 12 hours. So we're going to write 12 hours. Oh my goodness. 12 hours. There you go. So that's how you use rigor mortis and these charts to figure out postmortem interval. Okay, so we're going to move on to the second part. This part's a bit more tricky, but I'm going to try to walk you through it the best as I can. So first, calculating postmortem interval using Algor mortis. So what the hell is Algor mortis, right? So Algor mortis, if we go over here, Algor mortis is the cooling of the body over time, right? That heat loss. And so for the first 12 hours after death, the body cools at a rate of 0.78 degrees Celsius. And after for the first 12 hours, it cools at this. And then after 12 hours, it cools at 0.7. Not points. God dang it. I did it again. No, it cools at 0.39 degrees Celsius. Oh, I'm just going to cross these out. No. Okay. So this can sound a little bit confusing at first, but it's not too bad. So we're going to move back over here to the left side of the screen, and I'm going to highlight this right here. Boom. Normal body temperature is 37 degrees Celsius. So for the first 12 hours, right, 0.78 for the first 12 hours, and then 0.39 after first 12 hours. So this is what we're going to do first, right? We're going to calculate what the body temperature is after 12 hours. So all I'm going to do is I'm going to take my little calculator, and I'm going to put 0.78 times 12. Now, I got that 0.78 from this right here, 0.78, and then I got the 12 from right here. So it turns out that we lose 9.36 degrees Celsius after 12 hours. So what the heck is that in terms of temperature, right? So 37, which is the normal body temperature, minus 9.36, which means that after 12 hours, our body is at a temperature of 27.6 degrees Celsius. So I'm going to write that down over here. Keep a good note of it. So I'm going to write, here it is. After 12 hours, 27.64 degrees Celsius. Okay, super important. So what this means is that if our body that we find at the crime scene is above 27.64, that means they've been dead less than 12 hours. Because we know that at 12 hours, because the body loses 0.78 degrees Celsius per hour, after 12 hours, this is our body temperature. So if it's above this, they've been dead for less than 12 hours. So let's unpack this, right? Let's look at this first question right here. Number 1, estimate the PMI in the victim's body temperature at the crime scene was 33.1. So this is where we can use this information. So 33.1. Is 33.1 bigger than 27.64? Yes, which means they were dead for less than 12 hours. So I'm going to go ahead and put that, right? So I'm going to put if it's greater than 27.64, it's going to be less than 12. But if it is less than 27.64, it is more than 12 hours. It's a little bit hard to see, but that's okay. I'm sure you'll figure it out. So well, what am I supposed to do? I already know it's less than 12, right? Because it's greater than 27.64. So what the heck do I do? Okay, so here's your formula. We got a nice handy dandy formula for you to use. So the first thing is it's normal body temperature, normal minus dead divided by, straight lines, the change, heat loss. So let's go ahead and fill that out, right? So normal body temperature, we know 37 degrees. So 37 degrees Celsius. And then the dead body temperature we know is 33.1 degrees Celsius. Next, heat loss. Heat loss, how much heat did we lose? Well, we know it's less than 12 because it's greater than this body temperature. So it's going to be 0.78. 0.78. There you go. So let's just plug all this into the calculator. So first, we're going to subtract the two temperatures. 37, not 38. 37 minus 33.1. That's 3.9. Oh, it's not. Oh, yeah, it is 33. Okay. Divided by 0.78. Boom. So 5 hours. So we know this person has been dead for 5 hours. And then we'll rainbow circle it because why not? Next, well, what if it's more than 12, mister? Like, how do I know what's going on? So, it's pretty simple. Well, maybe it's not that simple, but that's why I'm making this video. Let's look at this example right here. What is approximate the PMI if the body temperature was 15.6 degrees Celsius? So this one can be a little bit tricky, right? But all we need is this key that we made over here. So after 12 hours, we know that the body temperature is 27.64. So is this greater or less than 27.64 hours? Well, let's check. Is 15.6 greater than 27.64? No, right? But it is smaller than 27.64. So we know that the body has been dead for more than 12 hours. So we don't need to do this. We don't need to do this part. Oh, come on. This part with this number. We can just skip to 27.6. Because we know 12 hours have already passed. So let's go ahead and do that, right? So instead of 37, I'm going to use the same formula, but my normal is going to change to 27.64. Again, I know this because if my temperature of my dead person is less than this number, then 12 hours have already passed. So I don't need to start at 37. I can just start at 27.64. And then minus my dead, which is 15.6. Divide that by the heat loss. Now, which heat loss am I going to use? This one or this one? Well, let's check, right? I know that 12 hours have already passed because I'm using 27.64. So I'm going to use the first 12 hours, or am I going to use after 12 hours? I'm going to use after 12 hours. So 0.39 here. So we're going to go ahead and put that into the calculator. 27.64 minus 15.6. So that gives us 12.4 divided by 0.39. Boom, 30.8. Right, so a little bit over 30 hours. However, timeout. This does say 30 hours, right? But remember, where did we start? We started at 12 hours. So past those 12 hours, the person was dead for another 30 hours. So we're going to add 12 to that because we started at 12. So we found out, whoa, not times 12. Whoa, whoa, whoa. Let's go back over here, please. Oh, no. Okay, plus 12. Ah! Oh. 12. Okay, there you go. So I should have just added it. All right, so bam. Now you know person's been dead for 42 hours. Where is the cursor? Oh, geez. Okay, here we go. So I know... go away. I know the person's been dead for 42 hours. 42 hours because I know 12 hours already passed here. And then the additional 30 that I calculated using this formula. So this equals 30.8, right? And then I just added the 12 to that 30. And I know this person's been dead for 42 hours. So this is how you do this assignment. Let me know if you guys have any questions. Please send me an email or leave a message on Teams. I hope you guys are doing well. And as always, take it easy, will you?